Oh, okay, there we are. Now we're back. Okay, let me double check. Oh, we didn't have the sound running for the background. Sound's coming up now. We got a good one. We got a good track. And let's make sure that this is going good as well. There we go. We got the Musax. We got the coinage. Okay, so don't mind me. I was just reporting spam on Twitter for the whole 5 minutes there while we were getting warmed up. So, but I think I'm pretty much ready to go. So let me give you a brief summary of where we're at, what's going on. So and an assumption, not quite an assumption I made, but because I didn't really make the assumption, I didn't address, I didn't think about it yet. So it's not the implication. Is that the word? What comes when it's not an assumption? Because an assumption is you consider something and then you assume that you fill in the gaps. But what is it when you don't consider the thing? Okay, got one of those too. Anyway, so we're going to split up. We're going to take money and we're going to split it up into coins. And the goal is that every transaction on the network should always have multiple inputs and multiple outputs. It should always look like splitting or combining change. And it should never be clear whether the change is being split or combined to another person or to your own change wallet. It should not. When you look at the traffic, there should be no difference between a coin join, a private send, and just sending somebody money. It should just all look equal. And if Dash rises in price to $1,000, then something needs to happen. Just inflate the currency or something. I don't know. Because it's not useful at $1,000. It has to be useful. It has to have utility. It is not digital cash. It is not Dash. It is antithetical to Dash for Dash to be worth over $1,000 or even $1,000. Because, or the other thing that you have to do, because one of the big lies of cryptocurrencies is that they're infinitely divisible. They're not infinitely divisible. There's a very finite number of divisions. Okay? 1, 2, 3, 4. 1, 2, 3, 4. That's the division. Okay? And if the dust amount is over here at this place, then that means you only have 4 decimal places to work with. That is not infinite. So you can't just well, you can, okay, this is a facade. The whole decimal place is a facade because really a sat is the unit. The Satoshi is the base unit. So, but the problem is the network fees have to go down if the price goes up. The network fees can't go up. And that the relative value of the network fee, the network fee, if Dash is going to function all, first of all, I think we need to get rid of network fees because I think that they're bad. We need utility fees, not network fees. And that's a different topic for another time. But basically, the masternode should run valuable services that people want to use and are willing to pay for to use. And by my approximation, they need to be willing to pay about, at today's prices, remember this is relative, but at today's prices, I think it comes out to about 20,000 sats a day. No, they need to get 20,000 sats a transaction, but that's calculating transaction. Okay, basically, you got 4,000 masternodes. They cost somewhere between $50 and $100 to run. Let's be conservative and say they cost $50 to run a month. So, and we're just going to talk in dollars for a minute. So let's say that there's actually 5,000 of them. There's only 4,000 of them, but let's be a little bit conservative in both directions here. Conservative on cost, because we could certainly get the cost to be $50 a month if they're paying more than that. And some of them are probably paying less, and that's great. Okay, so this is the dollar value, which means that per day, and then we'd have to figure out the number of users that there are on the Dash network to kind of figure out. But let's just break it down to what they need to make per day. So we can go back down to, so this needs to happen within 30 days, essentially. So they need to be making about $10,000 a day, let's say. So I don't think there's enough transactions to support that. Let's see, because if you took, well, the transactions isn't what we want anyway, but it could look basically running a coin join through a master node for every transaction that you do. Every coin join, every private send goes through a master node. You pick a master node, you say, hey, here's what I want to do, here's where I want it to go to. Somebody else chimes in, and you both put in your denominations, and then denominations go out in all directions, and the change is split evenly as stamps on the coin. So a coin at any given time might hold up to 500 stamps on it. Stamps being the 200 sats, right? Now, if we got rid of the transactions, then we get away with that, and we can still donate stuff to the network to make the denominations even, but we can also pay our specific master node for services or donate to our master nodes that we use. Anyway, that's kind of a little bit of a different thing. But anyway, what I'm getting at is they're not infinitely divisible. So if the price goes up, you cannot say that the base cost of a transaction, if we were to stick with transactions, transaction fees is how masternodes is supposed to be the primary way of making money. Supposed to be, because right now it's just the rewards. But if it was this, if it's what it's supposed to be, that would be way too expensive per, essentially what you're paying is the number of inputs. So take this number, the base cost is something like 40 sats, and then it's something like 40 sats per output, and then 100 sats per input. It's roughly that. You can see that comes out to about 192. So let's just put this up to 50 and put this up to 110. So that comes out to an even 200. But so if you add more outputs, then your cost is greater. If you add more inputs, your cost is much greater. The input cost is most of it. In fact, I think I got this totally wrong. I think the output cost is a lot closer to 35. I think that the overhead cost is a lot closer to 20. And so this would be closer to 145, or maybe this is closer to 25 or 15 or whatever. So that gives us 50. Yeah. So the cost looks a lot closer to this. So inputs are much more expensive than outputs, or the overhead of the headers. So if you want to have a bunch of inputs and you want to have a bunch of outputs, that's what your fee looks like. Well, if you're going to have 15 coins, because that's the only way that this can work, you cannot have a private send functionality in the way that it's currently done. It's just that incarnation has proven to be a failure. It's going to be a failure. We have to shift the paradigm towards something that actually is indistinguishable, that at the network level, this is the way that transactions are sent. But anyway, if we do that, we can't have, this just doesn't work. So we'd have to say if the price of Dash goes up to $1,000, and we can't mess with the SAT, because the SAT is not infinitely divisible. One SAT is the unit. That is the Satoshi. I don't know why people say it's infinitely divisible. That doesn't make any sense. It's obviously not infinitely divisible. You could make a system that was infinitely divisible, but literally the name of the unit is the Satoshi. That's kind of a big deal. How do people think that it's infinitely divisible when there's a base unit that cannot be divided? What? Come on. Okay, so all of that out of the way, this would need to shift over. So if Dash increases in value 10x, then correspondingly, the cost of a transaction must go down by 10x. Otherwise, you're paying 10 times more for a transaction, and that starts to get costly, especially when you are optimizing for clean transactions, not for dirty transactions. If you're optimizing for dirty transactions, that's what we're doing presently, but that's just the wrong optimization. If we're trying to make a digital currency, optimizing for a transaction fee, which is something that should scale with capacity, it just doesn't. The premise of it is wrong. If I told you that the more efficient processor you put in your computer, the more we're going to charge you to run it every month, that just wouldn't make any sense, right? You wouldn't say, the more coal you burn, the less coal you burn, the more we're going to charge you for the coal. What? No, that doesn't make sense. You can't say because the network has increased in value that we're therefore going to increase the things that are becoming more efficient, or should be becoming more efficient as the value is scaling up, right? So anyway, that's the thing. I don't remember where I was going with all that. But we're going, so right now what we're doing is we're saying, okay, money can have stamps. Stamps are the 200 unit. A 200 unit is a stamp. Anything that's below 200 is absolutely useless. It has no value because you can't, currently the hardware, or not the hardware, it's hard coded to not allow fees that are less than 191 because the fees are capped at 1 Satoshi per byte. And this doesn't make any sense, but it also doesn't make any sense because we don't run garbage collection on the ledger, and we should. We should have some sort of signing process and then be able to run garbage collection, and we should charge a fee for small values. The smaller the value is, the less long it should be allowed to live. So if I have a coin that has a value of, say, well, a coin, individual coin. So we individual coin, I would say that what we would do during the roll-up process is we could just say, however many stamps the coin has, it can survive that many roll-ups up to a certain point. Small coins get charged double or triple, medium coins get charged 1, and then larger coins, when you're talking about your tens, or your hundreds, or your thousands, especially your thousands, because those are masternodes, those should never get charged for a roll-up, because 1,000, that's a big number. We could, putting, what is it supposed to be, so many million coins where there is a finite number of whole coin, I don't think there should be any charge, because we can keep that in the database for time and all eternity, and there would never be any, you'd never run out of any space. But all of these small ones, when you're saying, okay, well, we could have 1 billion pennies, essentially. No, the banking fee for the network ought to be, if it's less than a whole, then you get charged per roll-up period, and eventually, if you just let it sit there, you lose it. And I think the same could be true of ones as well. Think of like a savings account versus a checking account. A checking account, you get charged if you don't make enough transactions. And a savings account, you get charged if you make too many transactions. So I think the same role applies. If you're just hodling, then you need to hodl a high number, not a low number. And so you just lose your change if you don't spend it. And this, I think, provides perhaps a nice balance between the idea that we need inflation, because inflation encourages spending, but we need appreciation, because appreciation encourages saving. The more to him who hath not, from him will be taken even that which he hath. To him who hath an abundance shall be given him even more. Good enough for God, good enough for me. Anyway, time to pop this Mountain Dew. But that's, my brain has been working on this while I was sleeping. It's been working on it this morning while I've been waking up for the last 4 hours. But yeah, I think that's about right. So if we, and how to get that proposal process going through, I don't know, but we can start out with what we have. We can build a better wallet. The problem is, all of the wallets, the whole idea of a currency in general, nothing works unless it has network effect. So we could effectively, with the strategy that I've worked out, we can completely drop the current implementation of CoinJoin. It's pretty much worthless anyway. It has almost no advantage. It has no advantage for money that's in circulation. Let's say that. There's no advantage for money that's in circulation. This has a definite advantage for money in circulation, and as long as Dash stays below $1,000, the transaction fee will be somewhere between less than a penny to a couple of pennies, a few pennies at most. Once the Dash gets close to $1,000, then we have to make a change in the cost of the transaction fee. The transaction fee cannot be capped at 191 or 192. It just can't, because it's not tenable. Because the fees start leaking into actual countable money to be able to have multiple transactions back and forth. And of course, this methodology is going to increase the size of the blockchain. So there has to be some method. We need software that can index the blockchain and basically lob off a whole heck of a ton of it. We need to keep around some indexes. We don't need to keep around indexes for zero value money. If the money has no value, then after so much time, the page just needs to show this money either has a value or has, this money has zero value. Transaction history is either doesn't exist or is too old. So yeah, somewhere there should be, but you don't need 40 gigabytes of old data. Okay, keep the indexes for the coins. That would be the first approach, because we can't make the change to the whole roll-up idea all at once. We need a couple of nodes that get paid a little bit extra, maybe, because I don't really want to incentivize this behavior because it makes it more difficult for everybody else. Because having something cost $50 a month to hold gigabytes of unused data and RAM to process it is just, it's ridiculous. It needs to be inexpensive. Well, I mean, then there's the whole idea that the Mastodon owners have 1,000 Dash. So if you've got 1,000 Dash, then what's $50 a month, right? But still, and you know what they're making in their interest, so to speak, or I guess it truly is their interest. It is the interest that they are making from their interest in the network. You know, it pays for those costs, but that's still, it's a lot. It's more complicated. It needs to be simpler. So anyway, I think there's a path. I think that there's a path that starts with client software, and if we can basically allow garbage collection, if we could implement garbage collection, which I think we should just move this thing into a real database, move it into Postgres. I think that it can be done. We could move it into Postgres. It would probably bloat the size, because the Berkeley DB I think it's going to be more efficient. I could be wrong. Postgres could be more efficient. There are other things that we could do, like using a compressed file system or whatever. There's some techniques that we could use to get the database size more manageable. But just if we put it in Postgres and we do a query that would take a long time to do, but we could batch it out and just start from the oldest time frame and just clear out unused coins, just garbage collect that database so it gets down to a reasonable size of a couple of gigabytes of the data that's actually about the coins that are in circulation. And then later, I really, really think we need to introduce a policy that low value coins, they just get lobbed off. You know, if you dust anything that's below a whole dash should be subject to lobbing. Because if we do that, I mean, literally, you're reducing the possibility for, okay, not billions, just millions. Just millions. But it's... So, no, it could be billions. Yes, it can be billions of coins with millionths of whatever. Anyway, cool. Okay, now I think I've completed that thought, put it all together, put it out there. Probably still more to explain. Oh, so the thing that I realized that I want to say implication, but what I mean is the implicit nature of the thing. The implicit nature of the thing is that large denominations are not generally as useful as smaller denominations, depending on the scale of the denomination. So at the higher end, I actually would want to tend towards smaller denominations. So for example, I'd want to make sure, this is a rule that I'm not sure how to make it off the top of my head, but I'll get there. So basically, within a scale of denomination, within an order of magnitude, I want to make sure first that I have 10 ones before I make a 10. And then I want to make sure that I have 2 10s before I make a 20. And then I want to make sure that I have 2 20s and an extra 10, 2 20s and 2 10s before I make a 5, or before I make a 50. Because you're going to tend towards, in the higher denominations, the smaller amounts. But the reverse is true as you get to the smaller amounts. As I get to the smaller amounts, I'm more likely to want to use a 50 than I am to want to use a 1. So I don't know if the same rules should apply or not, because we can mix up too. With this strategy, we can mix up as part of a payment. And that mixing up as part of a payment does not necessarily reveal information about the payment. Because you're going to choose a set of denominations that should be in addition to what you actually intend to spend. And so what you're going to see happen is a bunch of coin go in and a bunch of coin go out, and some of the coin going out, some of the coin going in is going to be from other people, and some of the coin going out is going to be to other people. That's the ideal, is that every transaction is a coin join request. And every transaction is also a private send. And every transaction is also unto itself. Now, you could have some sort of timeout to say, if you can't get the coin join within, so many seconds, that you could basically have some coin join on standby. I think you could do this. I think you could basically just have your wallet on standby and be ready for whatever someone needs. And then if we get rid of the transaction fees, that makes even more sense, because then, as is, we've got all this extra dash, basically tens of thousands of extra Satoshis that are just doing nothing, and we can turn those into hundreds of transaction fees per coin. So if you just have some stuff there on standby, mixing in at will. So take your coins that are maybe the least mixed or whatever, I don't know. But you just have some stuff that's sitting there on standby. Somebody puts in a coin join request. You have a bunch of denominations, and you maybe have a target, or maybe you don't. It doesn't really matter. But because it can, once it goes through the transaction, it can be recombined in whichever subset of the denominations. It'll be all right. But anyway, so you have it go through. And these would be XPub to XPub transactions. But so you have the coin join go through, or the transaction go through, whatever you want to call it. And you are going to get back maybe just as many coins to yourself and change as you sent out. You're just going to get some amount of coins. And maybe there will be some smaller value of coin that just gets absorbed into the cost of the whole. So, I don't know. I think that if we do go the route of having... I'm still on the fence about whether there should be any denomination down at the 10,000th level, but if there is a denomination down at the 10,000th level, I think its purpose would just be to load up the others with stamps. It would literally be the stamp denomination. Because the stamp denomination in of itself is just any multiple of 200. And again, this doesn't carry any extra information. Because the signal, so we're talking about signal versus noise. The less information there is, the more it is, there's a specific way to phrase this with the theoretical categorical uses of the terms that I'm not familiar with enough to use the right term. So I may be using the wrong terms, but basically the signal is the information that is distinct and important. And the noise is information that is unimportant. Now, in our case, what looks like to us noise in a transaction is actually a signal. It's a fingerprint. But what might look like a signal, this 200, is actually noise. It conveys no unique information. Knowing how many stamps are on a coin doesn't give you any unique information about the nature of the transaction, because the stamps just become part of the protocol, not part of the communication between buyer and seller. So the buyer and seller don't negotiate the stamp value. So therefore the stamp value does not carry any information about the buyer and seller. Does that make sense? That's kind of where I'm coming from. And it doesn't communicate any information about your money in your wallet. We could optimize these. We could say, okay, well, we know, the thing I showed earlier with the 35 and the 140 and et cetera, et cetera. So we could say, well, in my wallet, I want to have this distribution where I've got a lot of values that are multiples of 140, but I have some values that are multiples of, this, that, or the other. And so that when I pick two coins, I can always pick coins that have that amount of information. But that is a signal, because that is an intentional choice about your specific wallet and the way your specific wallet is organized, and that would over time reveal information. Whereas this would not reveal information. It would just be anytime there's a transaction, if the transaction is down in the dusty range, which actually starts in the 10,000ths, then that amount just gets split up among the coins that are in the transaction. That's it. So there's no information that's being told about the sender or the receiver with those values. So all of the value and all of the values for the coins are predetermined. So there's no signal in the value of the coins themselves. There's only a signal in the number of coins that are going, but we reduce that signal because we say we're going to send out extra coins and we're going to get back extra coins. And it could be a random distribution. So sometimes it's 70% change back to us from our own wallet. Sometimes it's 30% change back to us from our own wallet, or maybe even 0. But you can make that semi-random or random. And in that way, anyone looking at a transaction, there would be no signal in the transaction. It'd be XPub to XPub, so every address is unique. It would be stamp values all the way around for paying the transaction fees and transferring the coins back and forth. And then it would be denominated values that are known values for the amount of the transaction itself. But that wouldn't carry any information because it's just predetermined denominations. And then there are the number of coins that are going out in the transaction, and that won't tell you much information either, because there will be maybe a surplus or maybe not a surplus of coins going out. Maybe it's just someone splitting their coins into denomination. Maybe it's somebody just joining their coins together. We don't actually know who the participants are sending in the coins, because it could also be a coin join transaction. And we don't know who the receivers are. Coin join transactions, regular transactions, all look the same. So now that I've said that about 4 times over, and I've got it for reference, now I've spent half an hour just going over that. But I think this should be tagged. That was maybe important. That was maybe important. Okay, now I'm ready to move on. But I needed to get all that out there. That's all the work that my brain has been doing while I wasn't speaking yesterday, while I was just kind of going back and forth in the code and yada, yada, yada. That's the information. That's where I'm at. I feel really good about that in principle. But yeah. All right. Okay, split denoms. Just split coin to denoms. That's task 1 that I'm working on right now for this. Split multiple coins down, not up by default. Yeah, maybe. I'm not sure on that one. Allow picking preferred denoms. Yes. In the perfect world, and I wonder, I got one more thought, is, okay, what if we actually did do the coin join thing, except for stamps? Coin join needs to have stamp values, which it doesn't right now. meaning stamp values, meaning money that isn't spendable but isn't dust. It is used for transactions until we can find a way to get rid of transactions. Would just sending all ones xpub to xpub, would it make any difference if it was just all ones and all tens? No. No. If everything else that I talked about were implemented, then whether it's ones or tens wouldn't matter. Or whether it's ones or fives and twos or whatever wouldn't matter, because we would eliminate the transaction cost, we would eliminate the size of the blockchain, so we wouldn't need to optimize for size of coin. Well, no, I think there still would be some sort of side channel observable signal that I think it would make sense to do the denominations, the double wholes and halves. But essentially, and when I was, one more thing of what I was saying earlier, if you have small values of Dash that are just hanging around, the idea is that eventually they, just by virtue of every time there's a roll up, there would be some sort of fee, like the transaction fee. That's a storage fee for junk coins, the checking account fee. The way you get around the checking account fee, and there's not a transaction fee in this model, the way you get around the checking account fee is you just spend them. So you just have them circulate again. This lets us know that they're not just random junk. That basically we want to eliminate any of the coins for which the keys have been lost. We want those to eventually to go back to the network. That's kind of what I'm getting at. Is that if there's not some sort of service level validation. So say for a masternode, there's a service level validation. So those coins should never get rolled up. But basically every other coin, if you don't spend it, it should lose value, I think. Or I don't know exactly what it needs to be. Anyway, all right, so let me get on to the task at hand, because I'd gotten this much way done last night, and I got to the point where we could get multiple change addresses was what we need here. So I need to get a bunch of change addresses now. And any sort of transactional logging, just like with cash, it just needs to be done in a different piece of software. I mean, this piece of software, when I say different piece of software, I don't mean then from what the user is using. I mean basically from the full node. The full node's job should not be to keep your personal financial records for you. It should be to keep track of what's in the bank. What is there? It shouldn't. Even banks don't keep stuff around forever. Eventually and every day they do a roll up. They consolidate transactions. Okay. Oh, speaking of which, that reminds me, there's one thing I need to do real quick. I need to log in here, and I need to transfer some Mo-Nay-Nays. Well, I need to ask my wife what I need to transfer. Okay. I'll do that later. Okay. Oh, and did I mention the servers are ordered? They're actually ordered. Cost to denominate. All right, so I can run this again. What? I'm very confused. Ah. There it is. Okay, see here? Cost to denominate. So the cost to denominate this is in the realm of near to a penny, right? So blap times blap blap blap. Do you like those blap blaps? Hey, by the way, hello, how are you? What's up? Okay, so no, this is actually whole pennies right now. Whole pennies right now. The cost to denominate this, the value that I am losing in terms of spendable value, is 5 pennies in order to denominate this. If it's 30, so yeah, to break change on nearly $2,000. To break change on nearly $2,000 is going to cost me about 6 pennies. Am I willing to do that? Am I willing to break that change? Yeah. The problem is, it would cost me just as much, because let's go back to this. The problem with this model is that it's going to cost me just as much if I were to do, let's just move the decimal place here. Okay. So cost to denominate is the same amount. So as we get smaller and smaller, this is the problem. Is depending on the value of the units, now we're looking at was 0.3. So so let's go 0.3 times 5750 or whatever. Okay, so the cost of splitting $17.25 is about 6 cents. And as we go further, now once the money is denominated, it's denominated. But in order to denominate your entire wallet, it might cost you $1 or something. But this is a cost that, again, it's the buy-in cost at network scale, because once the money is denominated, you pretty much will never have to pay a transaction fee. So there's that. Because each of these has enough stamps to pay for a transaction. Now that's just kind of I think that number just happened there. Yeah, because we look at this one, it just happened to be 124. This 192, it looks like the cost of a fee, but it isn't really. It just, by chance, it happened to be 192. It's not actually related to the fee. Or it is in some small way, because the fee is used as part of the number that's calculated in order how to divide things, and this, that, and the other. But this is saying that 192 is just going to be thrown away. 192 couldn't be included in any meaningful way into any of the outputs, so it's just going to get thrown away. But we're saying these coins can be transacted back and forth on the current model 165 times each. before something would need to be split into a transaction fee to repopulate the stamps. And as things are going through, whenever there are just junk amounts, those junk amounts are going to go to stamp values. So they're going to be replenished all the time. So eventually what will happen is that number will get high enough that a new coin would have to be created, because once it hits 1,000 per output, then that coin would just need to be distributed, and we'd have to distribute that coin randomly. We'd have to say that, so that would be equivalent to a little over 10 cents, and we'd have to say that we're not necessarily saying that that 10 cents will go to back to you as change. It might be a bonus to the person you're transacting with. We would have to have it be random. Otherwise, in the case that this boils over, you would you would be fingerprinting that transaction to yourself, and then when you go to use it again. So as long as it's random, what happens in the case that the number of stamps boils over, then there's no additional signal. So the idea is just to get rid of the signal. The money is just money. The money doesn't communicate intent. The money doesn't communicate relationship. The money is just communicating numbers going apart and coming back together, and that's all that the communication is. And there may or may not be a relationship between the parties, because it may or may not be CoinJoin, or it may or may not be a purchase, or it may or may not just be someone taking some money that they got and redenominating it. And that would be basically any of the parties that are in on the CoinJoin could be supplying that. You know, it should just basically be selected at random. And if you're not doing it at random, then you are basically just fingerprinting yourself and not really fingerprinting anybody else, because you don't know how many people are participating. Whatever. Okay. So to get back to this with... All right, we have everything that we need here. So I want to actually run this. I want to try this out. So I need to do the create next receive adder. I don't know. Let me go back and look at this, because I think the thing that's missing is how do I create change? So I need to look for usage 1 or usage equals 1. All right, so we need to recover the key. And I think that we maybe should have a separate account. So we should have a specified account that is a CoinJoin account in the wallet. And we could basically, one idea that I really liked is, let's say that we take the last possible account, and that is our CoinJoin account. And then we iterate on the usage to mean the number of mixes. So 1 would mean 1 mix, 2 would mean 2 mixes. So rather than 0 meaning receive and 2 meaning change, 1 would mean 1 mix, 2 would mean 2 mixes. 0 could be the initial redenomination. So 0 could be the redenomination, then 1 would be 1 mix, 2 would be 2 mixes, so on and so forth. And so you could track your CoinJoin that way in a predictable manner. And then, so for internal accounting purposes, because the network doesn't need to know how you're doing this, HD path is entirely specific to the application. It's the network doesn't know what you're doing with your HD paths and how you're structuring things, and if you're doing it the way that you should, or if you're doing it a different way. It just doesn't know. So let's see. Yeah. So we could have a special account that's essentially the CoinJoin account for transactional, transactional purposes. And then we can use the other accounts to map to people. So right now what I have it doing is creating new recovery phrases, but really, in the general case, we just want one recovery phrase. And then the accounts would be the different people. And or we might want separate. We might want to say, okay, all of my personal accounts are one recovery phrase, and all of the shared accounts, or not shared accounts, but the what's the word to say it? Contact accounts are a different recovery phrase. Oops, hold on, let me get my brightness back up. There we go. Put it back on auto. So that's what we could do. And yeah, then for internal purposes of being able, we can easily know, okay, these were real transactions versus these were just splitting and rejoining. I'm not going to implement that right now, but I've just put a pin in that. That's a thought on this. And so, yeah, the usage would basically go as high as 16. I've also thought about being able to use both account and usage together to be able to do a hash. So if you wanted to do account by phone number or account by email address, then you could take a hash of that, and you don't have enough bits and bytes to work with in account alone. But if you take account and usage together, you have enough bits and bytes to uniquely avoid the birthday problem and have essentially an unlimited number of contacts. So that's another just thought. The 64 bits between, well, you actually only would get 62 bits, but the 62 bits, because there's the high order bit for the is this hardened or not hardened, so you have to throw away those bits. They're not usable bits. But with the other bits, you could take that hash, you could embed that information in here, and then you could, that the problem is the benefit and the drawback are the same. You wouldn't be able to walk the HD path in order to determine which accounts have been used. You would have to have that contact information entered in again manually. So if you lost your contacts for, however, and you lost part of your wallet, but you had your recovery phrase, and you had some contact that had sent you money, but you didn't remember to put them back in, then that money would be essentially lost. Their email address would essentially be the secret salt to the, or not the, but it would be a semi-secret salt. But if you allow walking the accounts, there's no association in the HD path itself. So if I just assign Joey to account 10 and Bob to account 11, there's no reason for that association. So that has to be kept in a separate file. So it's a matter of, do you turn it into a protocol or do you turn it into an index? That's kind of the difference between the two approaches. Okay, anyway, so we have all this next wallet adders. So this whole bit right here is basically what I need. So next wallet adders. I think I'm going to have to create a new function that is going to be, so this is creating next pay adder, but next pay adder is going to use usage 0, right? Where did it go? Where's the usage at? Oh, we don't even have usage here because we're dealing with an xpub, and the xpub is whatever the xpub is. Okay, and then here, this is create receive address. I could probably just make the usage configurable. Make it so that usage is by default 0, and that you could pass in a usage of 1. I think that's what I'm going to do. Because other than that, it looks like this is the exact information that I need. Let's get rid of this. And then on that matter, The only difference between create next pay adder and create receive adder is the difference of whether it's doing it from the X key or whether it's doing it from, whether it expects to do it from the X key or whether it expects to do it from a recovery phrase, which is an important distinction. Okay, so what is the next one here? So next wallet address for create next pay adder, for create next receive adder. Is this still create next receive adder? No. Create donation TX. That one we can't actually use. And then, wait, what was this one? Oh, okay. Right. And then create dirty TX, which this, we're basically, yeah, the denominate is a clean transaction. And then we're back to the beginning. Okay, so create next receive address is going to be, so what I want this to be is not create next receive address, and create is a strong word here, but again I'm struggling with async versus synchronous versus whatever. And feel free to drop a comment or say anything, by the way. See here. Hold on. Reporting the bot. So I needed to report the bot. I guess I didn't need to, but I wanted to. All right. It creates a strong one. I don't really like that word. What is this really? What do we call an address that we have control over? If I were to say get next blank adders, what would that blank be? Because there's a lot of terms that are overloaded. Internal is already overloaded. Owned, controlled. Maybe keyed. I don't know. But I think this is what I'm going to do. I think I'm going to set usage is equal to 0 by default. And then I'm going to create another one of these. I'm going to call it get next change address. Because I do think there's an importance in communicating the intention here. Oh, come on. Stop that. Go away. Stop it. Okay, good. Okay. Oh, well, this doesn't have a name. Handle count usage equals now. And I actually want to do this. Okay, what? Oh. What's up, Javi? Or Javi? Is it Javi or Javi? All right. What is this? Javi. Javi was the first thing I said, I think. Hold on just one second. Okay. Doot. Okay, where am I at? No, we're gonna have a get next. I think we'll call it xpriv adders. We'll distinguish between xpriv and xpubs because that's really all we're dealing with is xprivs and xpubs. Can I use ChatGPT for some help? No, ChatGPT will not be able to help. One, because the thing I was doing just now was responding to a message. Two, because ChatGPT doesn't know what I'm doing. So ChatGPT can answer questions that are essentially on Stack Overflow, and it may have a better statistical model for suggesting an answer that is more likely to be correct. But ChatGPT cannot come up with any new solution to a problem. It can only give you solutions. So, for example, if I say, "Hey, here's a key. Make sure you hide it from a thief." Right? If it's a car key, what are you going to do? You're going to stick it in one of those magnetic lock boxes, and you're going to put it probably under the front driver's side. I mean, it kind of depends on the car where the metal will stick to the frame and whether or not the car's been winterized. But if you're a thief, you're really familiar with these things on the different cars. And if you're the average person, you're not. So you're going to think of, oh, would a thief never look for this? I bet he'd never look for it under the panel of my front right, or my front left tire. But a thief knows that, right? So a lot of times when you think you're coming up with something novel, or where are you going to hide your key for the house so that nobody can find it? You're going to hide it in the potted plant next to the door, right? Where are you going to put your combination safe? Well, you're going to put it. People used to put it in their Rolodex. Now it's probably going to be maybe in your sock drawer or something. But where's your wallet going to be? It's going to be in your sock drawer, top drawer of your dresser, right? That's where you put your wallet every night. So there's these things where you think you're being sneaky because you think, no one's going to know that I'm doing this, but in fact, everybody knows that you're doing that. It's the opposite of fooled by randomness. It's fooled by systematicness. And that's what goes on with ChatGPT. You might think that you're coming up with something that's particularly clever or random to ask it to prove that it's intelligent, but you're just picking the same things that people generally pick in order to ask it whether or not it's intelligent. And so that question has been asked enough that it has the statistical information about it, right? So if I come up with a problem and I say, oh, here's a problem that an AI can't solve. If I were to come up with a problem like that on the spot and just say, oh, let's think of a problem AI can't solve, and then ask ChatGPT, it would come up with the answer, because in forum posts, other people collectively come up with that same problem and then they give the solution, etc. So ChatGPT cannot help with writing code that has novel aspects to it. It can only help with maybe retooling an algorithm. If the algorithm's well known and there's hundreds of blog posts with that same algorithm, and maybe the algorithm's in Java, but you need it in Python, then ChatGPT might be able to do that because it might have enough language model information to statistically correctly pursue the right path to port some code from Java to Python. I mean, I would not be incredibly surprised if I gave it a bunch of syntax and said, port this to Python, if it could come up with a working program. I wouldn't be incredibly surprised. I'd be a little surprised depending on the complexity of the program. But yeah, ChatGPT, it's a talking head. It's it's a Siri for Stack Overflow, but it's not going to help you write code. It's going to help you do what's been done before by others. There is no novelty in what ChatGPT is going to do for you. Okay, so get change adders, and I wanted to do something else here, right? Okay, get receive adders. And then here we have get next xpriv adders. And I think we just call it get xpriv adders because we provide the offset, if I'm not mistaken. Oh no, we don't provide the offset. The offset is, the offset is obtained here. Okay. Actually, this is non-optional. And so... we can make... Oops. And make usage non-optional. All right. All right, so now usage is not optional. I think here count shouldn't be non-optional as well. There we go. So get change adders, get receive adders. And receive adders should kind of come first. Well, it's what's more likely, but I don't know. I kind of like the idea of get next. I'm gonna move this around a little bit. Okay. Okay, so, all right, I know I don't like Git for this, is because it's potentially going to cache. So it's going to change something. So I need a different word than Git, maybe. I need a word that conveys that, because create is a little bit weird, because all that's happening is it's just caching information. It's not actually creating something that didn't exist. It's just checking and caching some stuff. Are you bullish in Dash? Absolutely not. Please do not invest in Dash. Please don't do it. Investing in Dash ruins what Dash is. Dash is digital cash. Dash is for spending. Dash is not for investment scams. If you want to run an investment scam, you've got Bitcoin. Take it to the moon. Dash is your money, your way. Make everyday purchases with digital cash. This is Dash right here. Nothing about investment scams. Hopefully they got rid of they did have a little investment scam crap here for a while. I was really upset about it, but thank goodness they got rid of it. Because there's some new partnership, and they got to make it clear there's a partnership, and then it just makes Dash look like a scam currency rather than what it really is, which is digital cash. So if you want to be bullish on something, go be bullish somewhere else. This is not the place for you. Dash is to solve a functional problem in the world, not to get someone rich quick or become a retirement strategy. Now, of course, some people in Dash community will argue that that's what they see it as, but then I think they haven't read the name. Digital cash. You don't invest in cash. Cash is a means of exchange. You invest in an economy, and I think that investing, am I bullish on the Dash economy? I'm bullish on the Dash economy, but not the currency. The currency is simply a currency, but the currency may enable an economy. But if I think that if Dash hits above $1,000 again, well, if Dash were to maintain, basically, if Dash gets above about $200, it fails as a currency, because it's psychologically too difficult to do the math to be able to figure out how to use it as a currency at that point. So if it stays below $200, but if it were to rise up above $200 in fiat value and stay there, it simply fails. They would have to do something. Well, first of all, we have to get to the functional economy. If we get to the functional economy, all of that investment crap should go by the wayside, because if the economy is functional, then the churn of the economy will overshadow any sort of investor push and pull. And that's where we need to get out of investor grasp. We need to be a very, very undesirable currency for money laundering by VCs and the like. And we need to be a very, very desirable currency for people who want to be able to spend internationally, who want to be able to spend with their friends, who want to be able to buy dinner. That's where we need to be very attractive. And so a lot of the calculations I'm doing right now are based on the idea that if Dash gets to $1,000, it's failed as a currency, and this is a lost cause, and I should be doing work for something else. And thankfully this is MIT, so I could take this work forward to something else. But if Dash is going to succeed as a currency, the price, I think $100 is very reasonable. I think anything between $10 and $100 is reasonable in fiat, because the dollar is kind of the atomic unit right now. Back when my grandparents were kids, a penny made a difference. Now a dollar makes a difference, but a penny does not make a difference at all. There's nothing you can buy for a penny. There's nothing you can buy for a collection of pennies. You have these systems, that kind of these token ticket systems, where you can go to, for example, the Nickelcade, and you can buy nickels, but the nickels don't represent money. They represent a specific sized object that works in the slot of the machine. Because when you go to a Nickelcade, you don't actually, so you have to pay an admission fee. Your admission fee is the cost of the Nickelcade. The nickels that you purchase at the Nickelcade they're just as meaningless as a paper ticket. They are simply a symbol, and a symbol that has a physical representation that happens to fit in a machine that needs a certain physical representation to work. The nickels do not communicate value. The nickels do not communicate monetary exchange. They communicate a symbolic way that's predetermined in order to get the machine to turn on. Because the admission fee is what you're paying to signal the value. And so in day-to-day, there are very few things where anything less than $1 makes a difference. And that's why, I mean, even Taco Bell, all these companies are starting to ask you, do you just want to round up, donate your 3 cents to education? What are you going to do with the 3 cents? It's a meaningless value. Look at all of the change you get over the course of a month. What is it? $10? That change could just as well not be there. I mean, and for some people, $10 makes a big difference. But I mean, if I had to account for it, if I had to do something with it on purpose, it would not be worth $10. It would be a liability at $10. What if we were to take all of my change, round anything that's 25 cents or below down, round anything that's 25 cents or above up. Because basically what you're doing is something's priced 99.99, the taxes bring it back around. So, just round down, take those, those couple of pennies out of the whatever, and things that round up, whatever, but if you were to take that and follow that general strategy, take all of my expenses during the month, I don't think I could buy my lunch with it. Right. So it's just, I don't think I could buy a bag of apples with it. Maybe I could buy a bag of apples. How expensive are I don't know what apples cost. I could probably buy eggs, maybe. Well, no, probably not actually right now. I could have bought eggs before. I don't know how much stuff costs. My wife does the shopping. I used to know that stuff, but prices have changed drastically. So But yeah, so it makes my skin crawl, the idea of somebody investing in Dash to get rich, which I think actually to some extent some of the people I know, well, it's believe that the value will increase over time. I don't know how to put it, but I don't know. Yeah, okay, let me get back to what I'm doing here. Get next. So I just needed these two get next, but then I need something like this. Oh, and this should be adders, not adder. Get next, pay adders. Get next, receive adders. Let's just take a look at that again one more time here. Get next, change adders. Get next, expriv adders. Get next, receive adders. Get next, expriv adders. Get next, expriv adders. Get next, pay adders. Get next, pay adders. Okay, now these look like they are correct. Oh, whoops, did I screw this up? I may have. Oh, whoops, I'm going to undo that one. So get next, pay adder. Oh, we have both. I could probably just get rid of this. And anywhere where there's a now function, that's a good indicator that that is probably an online thing versus an offline thing and needs to be gotten rid of. Or needs to be pulled out, rather, not gotten rid of. Needs to be relocated. And this is really get next xpub adders, is what that is. Is addresses really possibly undefined? I don't think that's true. By the way, I'm sorry if I don't mean to come off harshly to you personally. Just to put that out there. I just have strong opinions, and I share them liberally. Deprecated use address. Oh, what's this one we don't have to do anything about other than rename it? Alright, this is optional. Okay, where did adder come from? Alright, that's fine. I'm okay with it being internally shorter, just not externally. Oh, that's already there? Good. address. Sometimes I do the dumb thing. Well, now I would consider it dumb. Yeah, see? Look at that. Right there. So what I should do in this case... Wait, is that a separate function or is this the same function? Yeah, I should mark it like this. Or call it generated address or something like that. Okay, I'm not going to worry about that one right now. Or I am. What is this? Okay, that's better. Ah. Oh no! Adders. Should be addresses. Okay, I don't want to go through all of this right now. I kind of do. I mean... you know how it goes. Hold on. Set number. Okay. And there's probably a lot of stuff in the cache that has adder. Basically anything that's stored. I'm okay with shorter internal variable names and shorter function names. Okay. But for anything that's documented as over the wire, it needs to be address. That is its proper name. All right, so we went through that, but what was the point that I was getting at here with all this? There's generate pay wallet. I was trying to solve a problem in here, I think. Well, yeah. That's internal, so that's okay. Okay, I think we're back at the beginning here. And then do I have any adder equals? Okay. Is there any other place where we've got adder that needs to be swapped for address? I think I caught them all, maybe. Wait, what's this? Oh, that one doesn't matter. That can just, that's shorthand, that's internal. It's not public facing. Oh, we got another one here. Okay. Alright. And then here this becomes address. Okay, good. And then this one still becomes address too, right? Okay. This should be its own PR. I don't think I'm going to go back and make it its own PR because all of the complexity here is complexity that I'm managing. And since I'm individually managing it, and it's so early on, I'm not trying to. The other time I was trying to port this from, I was trying to port it from something else. I was really meticulous about the PRs, but this one, yeah, I yield that there is not much benefit to that. Outer infos. Okay, good. So now back to the idea of get next pay adders. And more importantly, the idea of denominate. Hey, Dungeons and Dragons movie's coming out. Twitter wants me to know. Hilarious adventure. I don't know. Well, as long as they meet in a tavern, I guess. And eBay wants me to know that that I need to pay money. Okay, paid. All right. Where does the outputs? Here we go. Hold on. That should have been TX adders. Okay, so when we do the find adder, that is probably where this account information should go. So I should say, I should probably be able to pass in a name like this, but the name can be a reference not just to, when it looks up the address could have information linking it back to another wallet. So I could say create a derivative wallet off of main. Main is account 0 of the recovery phrase. So create a derivative wallet off of main. Yeah. And I think with the friend wallets, what I might want to do is just set that number really high. Say probably 1,000 would be high enough. And just say that contacts start at 1,000 and wallets that are the wallets that you personally are switching through start at 0. Wallets that are savings, checking, etc. I mean, we could bump it up to 10,000 probably. It'd be fine because you're going to have what? You're not going to have more than 100,000 contacts. I mean, over many, many years, 10,000, yeah, possibly. People that you pay money back and forth with. I think 10,000 is actually reasonable that you approach that. Certainly 1,000. But 100,000, I don't know if you're going to do that during your lifetime, especially now with something that's not even used yet. It's going to take 10 years. So once Dash actually gets a foothold in the digital cash market, once that happens, it's going to take 10 years for it to become popular and yada yada yada. So we got 10 years to figure out these problems, but we need to get Dash to a point that it's ready to start. Because I think up to this point it's just been Bitcoin Jr., which is really a really terrible marketing play. Because that's exactly the opposite of what it is. Okay, maybe that's being a little harsh. So, Dash, I guess, no, it's not harsh. Dash is not competing with Venmo. That's the problem. Dash needs to be competing with Venmo. It doesn't need to be competing with Dogecoin. That's not good competition. It's going to lose. It's going to lose every time in the face against Dogecoin. Speaking of which, what's Dogecoin at these days? I might want to get a little more. You get a lot of Dogecoin. Almost 7.5 cents. Nice. Let's see. Ooh. Let's see, the highest it's been in the last year was 17 cents. Let's see, Dogecoin's a good investment. That, you know, you can turn pretty quickly, you get a whole bunch of it, double your money, get out. Dogecoin's great. You know, if you want to play Russian roulette, Dogecoin's good. Excellent. Probably the best one you can get into. You can buy thousands of Dogecoin. I want 1,000 Dogecoin. What would that cost me? So 10, 100, $70. I get 1,000 Dogecoin for $70. I could run a Dogecoin masternode. Okay. Why is this complaining? Because I'm not using it. All right, there's my handle. And okay, so what I was thinking with the handle is that the handle could contain more information and probably should. And the handle would reference back to whether it's saying, actually, I'm just an account on this other wallet. Or, but I think, so, okay, to do, handle should link to hash of seed for and account number of other wallet. I also think that the number of rounds of mixing should not be fixed. That it should be a fairly broad range, and it should happen over a long time period. It shouldn't. Mixing shouldn't happen all at once, because then all of the time data relates all the coin together. So this is another thing, right? So you can look, and I haven't actually talked about this before, I don't think, because you can watch the address flippy, right? So look over the course. Don't think of it over the course of a transaction. Think of it over the course of 3 days. Look at it over the course of so much block size. All of your coins are going to get mixed within 3 days, right? So when you see a whole bunch of coins start being mixed, and then a whole bunch of coins stop being mixed, well, there you go. There's your window. So you know those coins are related now. If there's some coins that didn't exist in that window, if there's one coin that started way before, way before this side. If there's one coin that started mixing back on last Tuesday and then finished mixing, here, it's obviously not related to one that just started mixing at that juncture. So there's just so much information that you have to consider that you want to eliminate. You do not want a coin join to happen quickly. You want it to happen over a period of weeks or months. So basically, you just want your again, this goes back to the concept of the long-term storage and yada yada blah. But you just want the money to move, or you just want the coins to move. Okay, TX header infos is defined but never used. Okay. Okay. I don't know how exactly I'd multiply that, but... Alright, so that's how we determine if it's denominated. It's that basic flow. Okay, console.info, tx adders, well, let's do adders info. This is not correct. One, two, three, four. I'm a little confused. Ah, here we go. Alright, so all the calculations I were doing earlier, they're all wrong anyway. Because they were all missing this. So now this is going to tell a whole different story. I don't know why I didn't notice that before, but visualizing it this way helped. So before, it's 165 per output, now it's 124 per output. Makes a lot more sense. Oh, another nice thing about this. Here's another great, just ingenious thing about this. Ingenious. Is that this allows you to coin join any value that you have. So you can take any value that you have and then you can reduce it down to a value that is sorry. So I could basically say, let me send in. Why does CoinJoin not work this way already? Okay, because there may be a way to not modify the existing system hardly at all and get some of these benefits. I still am a big believer in the denomination. But you could just... Wait, hold on. Can you? No, you need the denominations because if you... But, okay, so we could take... Let's say you've got some random value of coin and I've got some random value of coin. And we're both going to put into a coin join. And all that we care is that we just get... that it just gets mixed up, right? That's all that we care about. I can put in any random value of coin. It's just that I'm going to get back about, with that strategy, I'm going to get back about 7 cents less on the random value. And that, because the random value of, anybody who's putting in random value, that random value is going to be distributed amongst all the coins get back. So I can put in my coin of any random value. You put in your coin of any random value. And then things are just going to get split up. And so as long as there's not a big heavy leaning. So for example, if you put in your value as 100 dash and a bunch of random digits, and my value is 0.1 dash and a bunch of random digits, well, there's no way to denominate that in a way that really makes any sense. Because it's such different orders of magnitude. So you'd know that anything above 0.1 is going back. So they have to be in similar orders of magnitude. But I could put in a few coins, you could put in a few coins that are similar values, 2.65312, blah blah blah, and 3.15, and but if they're basically within a denominational unit, so probably if the total sum is less than 2 dash apart or so, then you can split all the money back out, and then we're just going to put stamp values into the individual coins. So I might lose 7 cents, you might lose 7 cents, whatever. But whatever the change amount ends up being, you just distribute the really, really tiny stuff pretty much, not quite, well. My point is that there would be a distribution that such that it doesn't say much. I might know. Okay, so if I know that the grand total that you put in, if I knew the grand total that you put in was 5, and I knew the grand total that I put in was 6, we still wouldn't know which 2s or 1s belong to who, as long as we say, okay, well, if this amount requires that a 1 goes back, then we can take, instead of splitting this perfectly into 2s, we'll take some of those 2s and we'll split them into 1s. But then you could fix that later on, because later on you could have stuff go in and you could mix it in again, and then you could mix it back up to a value that you like, and it would be indistinguishable from a payment. Yeah, I really like this idea. I think it works really well. But I was going to say you could just send them back out randomly, but you can't really do that, because what happens is when you send it back out randomly, no value is lost, and so the signal of the total value stays together, right? So if I send in a bunch of coins that cumulatively were worth 25.671, whatever, and you send in a bunch of coins that are cumulatively worth 27.251 or whatever, then when the coins go back, there would be a grouping of coins. You could go through all the permutations of the coins, and you could find a grouping that only that particular grouping was very close in value to the original inputs from the one side, because you're trying to match very, very clearly. But if you drop all the stamp values, the dusty values, then you lose the signal, because you just see a bunch of 1s go back, but you don't know which ones went where or why. And then if you further separate those by time and all that, then yeah, you could get this. You get it working out. Okay, so is it time to do this? What would I be doing here? And you could broker this the same way that CoinJoin is brokered. Yeah. The only advantage to CoinJoin over doing this independently is that CoinJoin doesn't always take the collateral. It takes the collateral at random. I wonder what is the CoinJoin collateral, because it's probably so little that it doesn't matter. With this, you could just flip that around. You could just say you pay the node to be able to have access. And an invalid access just costs more. So if you sign a message with your key, this is good. This is good. Again, there's just so much going through my head. There's so much that I'm trying to sort through and figure out and take what I know. And, it's a lot more about the thought process than it is about the keyboard work today. The keyboard work is important because if I weren't doing the keyboard work, one, it's difficult to justify. It's the output is difficult to quantify. Well, I mean, here the output is low quantity, but it's clear that the focused effort is there, is what I'm getting at. But the real value in the keyboard work is just being able to explore and see what things look like, and let it's a springboard. The code hopefully will become very valuable, but it's just a springboard. It's just working through a thought process. It's, essentially, this could have been done in a spreadsheet, maybe, kind of, sort of. I don't know if that's actually true. Okay. All right, sign to target. Okay, this looks right. I'm a little confused on this. Because there's a whole bunch more rules that we could add to this, little subtle variations. But I think this is essentially it. So math.random actually should be crypto random at this point. What is this song? What's this piece of music? Oh, Metroid Prime Gravity Suit. And in this case, I don't think putting the outputs in random order actually does anything for us. Oh, and another thing I was going to say. So if you were to just put a bunch of payments out, let's say that you needed to pay a bunch of people and you just paid them all out. And you don't split up the change for yourself, which is how things presently work. And you paid, these very finite amounts. You're going to be paying them some amount that has some sort of meaning, that has some signal to it. So for example, you might pay them out 1.0 dash, or you might pay them out in the approximate value of the dollar value of dash at that time. Now you can correlate that. You can know approximately, pretty much, within a couple pennies, given a block, what the value of dash was within that 2.5 minutes that block was completed. The block time is more or less well established. So if you look at a bunch of payments that go out, it's highly likely that there will be some sort of signal in the payment, either because you've chosen a value for a payment to someone else. Well, no, because you've chosen a value to a payment for someone else and you haven't chosen the value back to yourself as change. And because there's typically only one address that comes back to yourself as change, that change address, the value of that change address is going to contain a signal. Because there's a signal, the noise in it is the signal, the fingerprint essentially, because the amounts that you chose, the amount that you have will be seemingly random. It will be unrelated to today's dash value, the value of the coin that you have, if that's the way it was transacted. So when you get it back, what the value you get back is more likely to appear random than the values that you send out. That's what I'm trying to say. And so that randomness becomes signal because all of the other values will look somewhat regular, but the value that comes back will look irregular. And that will give it the signal. That will, and typically the output, the last output is the one that is the change anyway, which that just needs to be randomized. In fact, we could probably actually, I'm going to contact Will about this right now. Okay, where? Okay. Okay, good. All right, next here. Oh, and you know what? We don't need to return on the dry run yet. All right, let's see if this works. I need to go pull in. So Amazon's been doing a horrendous job lately. I should show you what it did, but I think I showed before. So basically, what is that? $1,500 worth of hard drives was delivered in a ripped plastic bag. I mean, this. I thought this stuff was Tyvek, but I guess it's not, because Tyvek is definitely stronger than that. I don't really know what Tyvek is. I just know that it's really durable. But anyway, you know, it was just delivered and with no padding, no bubble wrap, nothing. Just literally the Tyvek like plastic bag. Okay, $1,500 worth of hard drives delivered in that. Then next, I think it was 2 hard drives were delivered in a box that was big enough to put a microwave in. I kid you not. It's big enough for a microwave to fit inside it. It was, depending on the size of the microwave, a little smaller, a little bigger. Maybe the dimensions were a little more square and less rectangular, but approximately the size of a microwave box. 2 hard drives come in that. And then another one comes in the size of like a 24 pack of soda with 4 hard drives in it. And those ones had padding, but they were all crushed up because they had no... Because they looked like they were big, and so they go on the bottom because they're big, and then big things go on top, and they got crushed. It was insane. So I've got a couple of server components that have arrived, and it's kind of snowy, rainy today. And the Amazon people, you know, sometimes they just throw them on the steps. They don't bother to get it up across the step to the doorway. You know, in fact, I should check on that right now. I will check on that right now. Give me just 1 second. And then I'm going to need to take a break because my brain is just buzzing with so much things I'm thinking of that it's... I need to take a break. But we can get a little bit further before I do. I think I can test to see that this works. All right, what does it look like at the door right now? What does the door look like right now? Show me the door right now. Doorbell. Okay, I cannot see the packages. But I believe that they are there. Let's see. It's already 4. Okay, it might have actually been brought in when my wife answered the door. I actually don't see the event of the packages arriving. I might have gone to the mailbox. Okay. Oh, that'll give me an excuse to get on the 4-wheeler. I like to ride the 4-wheeler down to the mailbox. Okay, so what was I going to do? I was going to look at coins here. Okay, and so we're just going to take this one here, and I'm going to say denominate Why would it need that? Yeah, I still need to update that. Okay, so we need to have inputs here. Outputs. What are we doing with the output? Whoops, sorry. Output just needs address. Let's see, create dirty TX. Get balance. So at some point it's going to iterate over these. Is it assigned to target? Nope, not here. There we go, right here. This one. This is the one. I'm going to copy this over for now. We'll fix it later. There we go. So that's what I got to publish to the network right there. I got to get the dash site CLI installed at some point. All right, I'm doing it. Changing the name in all one places that it's used. I actually want to do this. Oh no, okay, I'm good at that. This should actually probably be its own function here. I don't know if that's actually necessary. I'll leave it for now. Yeah, this is... I think this is long enough. I could warrant... Okay, what am I going to do with that info, though? Okay. I'm quite cryptocurrency stupid. Any recommendations for resources to not be? In general, the more you know about cryptocurrency, the dumber you are. As a broad rule. So, it's kind of an oxymoron. Haven't touched anything with cryptocurrency in about 10 years when I did some BTC mining. I'm curious about the tech side of it. Nothing has changed. No, well, okay. I'm being a little cynical and a little snarky there. But I think the best resource that I've got, I mean, it's how do you explain a Rube Goldberg machine to somebody? You know, that's how I feel about it. A lot of it is very Rube Goldberg-y. So to try to explain it, you're explaining nonsense. How do you explain nonsense? You know? But I think looking through the Dash tools, this is what I would say. This is the documentation that I've created. There's some documentation here. So here's a high-level glossary. You got to scroll down to the glossary section. But here's a high-level glossary. Then there's also there's two bits here. Okay. The anatomy of a blockchain transaction. And then there is the Dash HD glossary. Very little of this is specific to Dash. Most of it is general across all Bitcoin derivatives. The things that are the most specific to Dash are really just bits that get twiddled, implementation details. Well, not most. About half. About half of the things that are specific to Dash are there's faster block times, the sizes are different, the fees are different. It's meant to be something that's better for digital cash. There's a masternode network for proof of stake, which essentially is you have to have 1,000 Dash in order to run a masternode. And the signature that you use for that coin gets verified against the signature of the node. So basically that you kind of cross-publish. You use the coin's private key to sign a public key from your server, and you publish that, and then your server can respond with a signed public key of the 1,000 Dash. I don't remember exactly how it works, but it's kind of like that. And then the masternodes, when they reach a quorum, and this is what prevents someone from who's a disinterested party from just spinning up 1,000 more nodes or 10,000 nodes and stealing the network, is that you can spin up 10,000 nodes pretty easily. You can even do some funny tricks to make it so that your CPU power and all that are effectively zero. You could definitely, in terms of just raw cloud compute power, it would be super easy to overtake the Dash network for a small amount of time. Well, I mean, you have to have the tools to do it, but it would be cost effective to subvert the network for a small amount of time, and you could do it. Because you can spin up 1,000 instances of something on Amazon, or you can't do it on DigitalOcean. You can't spin up 1,000. And you probably can't spin up 1,000 on Amazon either without going through some sort of approval process. I would imagine there's some limit. But assuming that you can, well, I mean, you could just run 1,000 virtual machines. Well, I guess virtual machines would be virtual. You do need extra CPU capacity. But the point is that it's within the realm of reason. It's something that can be done, and you could do it for a short amount of time, and then you could just get rid of them, and then you would, maybe you'd pay a couple $100 or a couple $1,000 for the few hours that you did it, but it would be relatively inexpensive to do and practical to do if you had the other pieces. If you had all the other software for whatever subversion that you wanted to do in place, getting the CPUs deployed is not difficult. That's what I mean to say. And so with Dash, having the masternode network, it is difficult to get 1,000 Dash. You cannot buy 1,000 Dash 1,000 times is 1,000,000. So to get another 1,000 masternodes would require 1,000,000 Dash, and there's not 1,000,000 Dash freely available to purchase. So the cost of Dash would start to go up exponentially, or maybe even geometrically, as you are buying up all the Dash in order to fund the masternode. So it would be a really long and slow process. There'd be a lot of price volatility during the time that you're doing it. It would be very difficult for you to get your money back, because if you sold the Dash, you'd have to sell it very slowly. Otherwise, you'd create a huge excess in the market and the price would drop to zero. So that is much more difficult because it takes a lot more time. It's not something you can do in an instant. And so the masternodes, they will vote on transactions, and when they reach a quorum has voted successfully or approvingly, that transaction is guaranteed to be approved, and it cannot be subverted by minor nodes, because Dash is primarily proof of stake, and it just has some vestigial proof of work. And then other unique things about Dash, CoinJoin is a way to get around fees for certain transactions that look a certain way. And that is of little practical value, because to do what you would do without CoinJoin would cost you only pennies anyway. So the CoinJoin itself doesn't add much, but it is built into the masternodes as a way to communicate intent to spend funds in a particular way. So, but if you are thinking more broadly, I don't think there's really any innovation among the Bitcoin forks. I could be wrong. I think that Dash is the only one that's trying to do something from a technical perspective rather than, say, a marketing perspective. And then, what do you think? In Ethereum, the other ones, you kind of have two more types. One is Ethereum, which is basically everything is just colored coins. So people just run things on the Ethereum network, but they almost run it like a VLAN. You could think of it like a VLAN, right? You're familiar with VLANs. I think that's basically what it is you have a colored coin. There's a little bit of extra data in the packet, and you say, this is a coin, but it's not really an Ethereum coin. It's a sub coin. And I think that those coins can sometimes act like a Lightning network. Sometimes maybe they can go off chain and go back on chain. I'm not 100% sure. And then you have a bunch of proprietary might be a strong word, but typically proprietary blockchains, where it's basically, they are literally a way to launder money. They are literally faux securities where a company starts a business around a blockchain, and investors can buy the token before it goes public. So but it's not an ICO because those were already declared illegal, but it's basically just more of the same. It's just fudgy ways to do things. And then investors have to diversify, because if they actually were to put all their money into this for it to funnel over to the other party, then that would be clear that they're laundering money. But so what they do instead is they diversify the money so that it goes in places where some of it's going to lose value or it's not going to transfer over correctly. But most of the stuff in that space is pump and dump technology. It's marketing technology, or the technology, the innovation is the marketing of it so that you can get people to invest in something you're going to sell. Okay. Let me see if I can get this done, and then I need to take a break. I'm also kind of hungry. I think if I run this, I think it's going to work. Coin inputs. Okay, so I'm calculating this ahead of time. Yeah, I think that those, in terms of Bitcoin networks, it's the best documentation I know of because I wrote it. And I collected everything together and showed how they relate, because most of the documentation evolved naturally over a period of years. And there's not been an effort, because again, most of the innovation is in how to market and spin. Most of the innovation has not been on the technology side. And so there's not been much of an effort to get things together. Also, it's not very useful, right? Bitcoin has about this much utility. So there's not a technical advantage to go back and figure out how the stuff worked. You do find a little bit more up-to-date documentation in things like Dash and Litecoin. But in terms of the original, and that's another thing that's really confusing, is that there's a lot of documentation out there, and the difference between Bitcoin and a lot of the other ones tends to be magic numbers. So, and there's lots of different magic numbers, and that's explained in that documentation. But, there's a magic number for all of this stuff developed over years and independently, and there's a lot of sprawl. But the way that we use addresses today is not the way that they originally were. Originally, it was just a pub key hash. It was a hex string, and then they decided to do base 58 encoding, and then they decided all these other things. So you got all these layers, and there's lots of stuff that's completely irrelevant because something was being shoved down into a really low protocol layer, and then later on they realized, this could be done at the application layer. And so the way that transactions are on the protocol layer are super complex and a million different ways to do them, but the way that they're actually done in practice is the way that I'm doing them here. So the -tx source code would be good for understanding the way that transactions are put together. Basically, it's a header. It's a mismatch of different things. Some things are big endian, some things are little endian, some things are AS1 encoded. Some things have a size that precedes the payload. It's just a complete hodgepodge of different standards that had evolved at different times for different reasons. So. Okay, so I think the dry run, I could improve the dry run on both of those quite a bit. Because I think that printing out what happened should actually happen before it happens. All right, so here we go. Wait, did I do dry? Oh, I did dry run. Okay, let's not do dry run. Let's do it live. And it is sent. What? Oh, okay. Okay, the values look strange. Okay. It's not showing the extra zeros. So there's only 3 significant digits here. Actually, maybe only 2. What did I do? Let's sync. And then let's do coins. Alright, there we go. So this will be interesting to see. Because now I'd like to represent this differently and show stamp values. So instead of showing this amount like this, actually, let me go ahead and just fix that. Okay, so I put a negative. All right, doing it this way. You know, another thing that I really like about having the stamp value there is that it does have an indicator of which transaction something came from visually, which is actually good because that information is on the network, whether or not. So that value gives it an appearance of having some level of uniqueness. You can say, oh, well, these things go together. But yes, you would know that they're related just by looking at the transaction on the network. The fact that they have the stamp value that looks kind of signalish is actually only a visual indicator. It makes it visually easy to see that they may have been part of a similar transaction. It does not actually make them more distinct as coins. It does not actually provide any more signal value mathematically. All it does is visually show. So if I was to look at these, and this is good for me personally, because if I was to look at these and the values are super similar between them, I'm going to say, oh, those must have gone through a transaction together. Now, as a human, that's actually a good signal to me to know, oh, well, if I don't want to, if I want to confirm that these things were together in a transaction, I can spend them together. If I don't want to confirm that they were in a transaction together, then I could spend them with something else that's dissimilar in some way. But this gives me the same cue that would be immediately obvious to any software tool looking at these. And in fact, when I think about building a software tool that does this, it kind of helps me to kind of imagine what the amounts would look like, because the amounts would tell the story of which transactions they were part of. Because different transactions are going to have different fingerprints by virtue of the transaction, not by virtue of the amount that went through the transaction necessarily. So the stamp amounts, they make it easier to visually identify things that are very, very easily discerned simply by looking at a transaction and walking backwards. So basically, it's almost like you get to see, like you have here, right? Transaction ID. These two things are similar in this way. No matter what values went in, and no matter how the same the values are going in, that doesn't make any difference about what the transaction ID is. And so what we see here is that the stamp amount will have somewhat of a correlation to the transaction ID, and I think this is actually a good thing because it gives the visual signal. Now, if people were to see this, they might misunderstand it because it may not be intuitive that this is showing you that these are related in the same way that any software tool can easily see that they're related by this, because most software tools wouldn't show the transaction ID. But as these go into another transaction, they'll become more different. So the more different transactions they go into, the more different that they'll become. Well, potentially, because there's only something in the realm of 500 possible different values that this could be. There's a very limited set of what the stamp value could be. But the stamp value corresponds not to the signal of the money transaction, but corresponds to the signal of the transaction itself on the blockchain at that block. Well, within that block. Really, just the transaction. Okay. So that's cool. I wonder what else I could do to make it more distinct, visually distinct. Because I kind of want to say that this is some number of stamps, right? So this one is... can't remember. Let me see here. This should not be hard. My brain should be able to handle this. What is it? 83 stamps, right? Okay, good. So this corresponds to 83 stamps. So we actually, I think, want to split these out into two different things. So rather than amount, I'm going to comment this out for now. To do, show both. So there's denomination. A little confused. Why is this having no impact? Oh, got it. There we go. Now that's back on track. Let's see. There we go. Okay, what is this? Oh, right, because I didn't actually... Oh my goodness. No. Let's try that one more time. Cool. Neat. All right, well, hey, I should have done this a lot earlier, but we totally deserve a little hurrah there because it denominated. Somebody just sent a message. Well, it was Ryan, in the random channel about connecting my brain to GPT-4 with JavaScript. That actually sounds like it might work. So there's these things you can put on your head that measure electromagnetic pulses. So GPT is a model that if you give it a bunch of data points, then it can, does statistical analysis. So people have repeated patterns. So when you think of a certain thought or you have a certain feeling, certain region in your brain will activate. Most people, similar regions in their brain activate for similar things. For you, your life experience is catered. So maybe not around. So if I were to tell you, think of a car, that may not have a similar pattern to what someone else has, because that might activate speech centers in your brain as you think about the word. Some people have aphantasia, some people have aphasia, some people, and then what memories you have or beliefs you have associated with a car, what color you think that it might be, whether you think of you know, a BMW 325iX 1985 cherry red with convertible hood or not is probably dependent upon whether or not you're me. So there's certain things that are very, very different, but you could train an individual person's signals and you can have it translate stuff because your signals, it's just like learning a language. You just be learning the electrical pulses that fire off in somebody's brain and the minute differences. I could see that maybe working. GPT is meant to be trained on, like, I said like, dang it. It's meant to be trained on very, very large data sets, and I don't know if you could produce that much data, because then you'd have to give it the correct answer as well, you know, what you're actually trying to do. I don't know, maybe you could. Sounds interesting. Anyway, we're going to go ahead and denominating works. Okay. Yeah, I need to take a break from this, step away from it, let more things settle in my head. But what we're going to do when we come back is we're going to let's see. We're going to see if we can run a denomination process where we link a particular address to a particular denomination. I think that's the next step, because I'm actually going to do a transfer of money. Think about this. Okay, music's too intense. I'm going to turn it off. Also, let's see who's watching. Where do y'all want to go? I'm gonna do. Let me see if we got any good options here. If we don't have any good options, we'll still take whatever options we have. But we're gonna do a raid. So, but when we come back, I'm going to do this. Except instead of only using change addresses, I'm also going to use some specific addresses. So we're gonna have some ability to specify basically address amount. Probably address :amount, comma, or maybe use the CSV. And then the change addresses, so it's going to send specific amounts to specific places. Means that we need to have those specific amounts, so we might have to split up things again. And then, I don't know. Maybe I'll run it from a spreadsheet. Maybe I won't. I'm not sure. I think a spreadsheet might be a good thing to try. That'll be easy to do. Anyway, so we've got, hello, it's Rufio. We've got Watanium? We're gonna go. We're gonna raid Watanium. Jutanium. It's probably Jutanium. TypeScript compiler in the browser. Okay, Jutanium. Raid starting in 5, 4, 3, 2, 1, 0 now. Oh, wait, now the countdown starts. 5, 4, 3, 2, 1, 0-ish, now-ish, and we go. Adios.